Here we go. Here's our main electrical panel. It has been wired and everything is labeled. The way this works, you have two-phase power, nominal 240 volts coming in. So you have 120 volts on one, black with red stripe, 120 volts on the other, black, and you have a ground. This terminal for 1/2 the voltage, you attach it here, and that powers this plate. It goes up behind everybody here, and the little fingers on it stick off. You can see them there. The exact mirror image here on the other 120 volts. That plate is energized, and those fingers stick out here, and they're laced. I can't do it with, I don't have two free hands, but they're physically laced back and forth, which is how you use 240 volts. If you have something like a dryer, we'd call it 220, but voltage is nominal and confusing, so let's not go down that road. But when we have a double breaker, which is what this is, you can see the handle. It's difficult, but the handle is tied together, whereas this is a single. Each of these is a bay, a single breaker here, and then this 220 volt breaker occupies two, and the handle's tied together, so it operates as one. But the reason that's two together is because they go in a place just like this, side by side. So one of them is on this 120 volts, and the other one is on the other 120 volts. And so they stack vertically on one side of the panel. However, they've got both voltages, so we're back to the major voltage that this panel has, which is 240 nominal volts. I may be a little bit maybe using nomenclature a little bit incorrectly here, but essentially that's what's going on. Most of our circuits are 120 volts for ordinary things like outlets, lamps, some, I'm trying to think of other stuff that we've got in here that needs power. That's going to be with 212, so that's a two conductor two conductor number 12 wire, and they don't count the ground, so there's two voltage load-bearing conductors in here, and then there's another, you could call a conductor, which is a ground. So each of those has three conductors inside, but it's called 212. Then we have some 210 here, which is just two conductor, but it's a number 10 wire, which is heavier, and you'll see that orange, that goes over to the dryer, because the dryer is going to have a heating element and a blower, and it's going to draw a lot of electrical current, so it's got a heavier service. And you just have yellow here in this outlet for the washing machine, because that just needs to turn the drum, and that machine only is 120 volts, or whatever you want to call it, 110. We have another orange wire here that's a three conductor number 10, and that goes right through and over, and it goes all the way down to, this is the 210 goes into the junction box, which is where the hot water tank will go, and the 210 will supply the hot water tank. It is 220 volts, but it has two heating elements, so you just need two conductors there, one for each element, to run at 110 volts. This circular orange is actually 310, and that goes over here to the dryer. That was my mistake before. So there's three conductors and a ground in there, and that's because I believe one of the items is 120 volts, like the control unit inside on board, and the blower and or the heating element, it will be 220 volts. So it's got a couple different sub-assemblies inside the machine that call for different voltages, so you need to have multiple conductors to take care of that business, from what I understand. And some of this black is 212 as well as the yellow. The black was just what was in this here from 20 years ago or something, so we reused it. And then we've got our ground, which is one contiguous loop from the ground bus in the back. It goes all the way out. It goes through two different ground rods. This is an 8-foot, 1.5 inch diameter rod driven down into the ground till it's flush. And we go through the lug, and then we loop over to one 6 feet away that's been buried, and then we loop back through the lug, and we go all the way back to the panel, and that provides code grounding. However, you're not technically supposed to put both ends through one opening. We're going to modify this, but we got our sticker for our rough-in electrical, and we got our sticker for our panel relocation. Everything's been labeled, so normally when you put the finishing plate on here, you can't even see those, and you just use the legend on the panel door when you come to operate this thing normally. But the first step when you take the panel off, because you have some kind of other issue, you're modifying things, these flags will be here, and everything's called out on there so that you know what it is that you're operating on. So we hope that that's appreciated by whoever's in here next. But yeah, then our major service here comes out. This is aluminum, and it goes around the corner because we can't be inside the structure more than 5 feet, so you can go around and around. But we had to run all the way over to our new meter. Put the new meter core in. Let's get the little tamper. It's not a lock, but it's just a tamper guard thing, so you know that nobody's been in here to fool with it. And then we went back up, and they connected us on the cable and took us back out to the transformer. So we have been energized. And so if we did something like turned on our breaker, so we've got, actually I can show you, we're hot till, we've got 120 volts there, and we've got 120 volts there, but these are not energized because our main breaker is off here. So let me just drop that piece of equipment on the floor, and then we'll throw this on. And now this is why we keep this covered, because now when this is actually on and not, oh, screwed it up, totes. So it's just flashing now. It hit the floor so hard that it doesn't beep. Anyway, those are hot now. So this system is on. However, each of these individual breakers is off. So if we want to try something like bathroom lights, we can turn those on, and we can come over here and we can try bathroom lights. Shebang, boom. And we got things like a fan and an outlet too. If we want to try kitchen lights, I've got one lamp on every circuit here, so we can turn the kitchen lights on. And then as you come in here, I believe it's the first switch. Yep, boom. And the second one would be up there, which doesn't have a, oops, I'm stupid, there's no light bulb, and I guess I have a fixture on every circuit, but only two light bulbs floating around here today. So anyway, that's how that kind of works. We like to, for safety's sake, leave this not energized until we've got that covered. But lots of little things to do. We got our junction box over here buttoned up. Everybody, except for the hot water tank, has been wire nutted together and taped the wire nuts and folded nice and carefully back in there. And we closed the plate, you know, covered the panel. We're going to, what else are we going to do? Oh, we have to finish up a little bit of a switch here to turn the light on back there. We changed our mind. You can roll out the refrigerator to go back into this utility room, but in lieu of that, if you just want to check something or change a water filter or what have you, and you're not feeling up to that, what we're going to do is I'm just going to frame out in this wall bay here. And instead of one of those chintzy plastic access covers, this will just have like a covered door that is nice and finished. But you can just open the covered door and flip the switch, and the light will come on down there, and you can crawl along in here, and you'll be able to look. This is where we'll put all the filters and purification light for the water system, and you'll be able to check those, and we'll have a little storage here for some extra filter elements or what have you. But if you need to get the hot water tank out or do any other kind of more serious kind of work in there, most refrigerators have wheels, and you can just roll it right out of the cavity. So if you're seasonally shutting the place down and you're doing things like bleeding out the water and this and that, you can do that if you like. So that will be how we slice that. And we put an electric heater back in. This came out of here. This is just the fixture box for it. The guts and everything can be installed later. You just got to have this here so you know what to fit drywall around. So that's in there, and it's got a little, I got to bring one more circuit of electricity over into the box and leave that hanging raw, send it through here, and it's not going to have a switch or anything. It has its own onboard switch. It will simply be another breaker in here. And then we'll be in a position to start seriously considering putting insulation and drywall, which mostly is just this gable end wall. These interior walls don't need it. The end of this gable does get insulated, but we're going to do a lot of matched lumber, this tongue and groove micro bevel cedar that came off of the floor here, and we may need to get a little bit more, but we're going to use that in the bathroom, I think, and in a lot of the ceiling space here, maybe even on this knee wall. So that's something that we really want to get into ASAP, but there's just a lot of little loose ends to tie up. So we're going to tackle those this week, and then we will see you.